Alright, for number 1 here for this quiz review, we want to find the measure of each of these angles that are marked here. So we have 15x plus 12 and 13x plus 28. So first of all, you'll notice they're along a straight line here. So that means that together they're going to add up to 180 degrees. So that'll be our first step, is to set up that equation here. So we'll have 15x plus 12, and then we want to add that together with the other angle here, so plus the 13x plus 28, and once again, since they're along a straight line here, that means they need to add up to 180 degrees. So I'll set that equal to 180. And then, like normal, whenever you're solving an equation, combine like terms first. So our like terms here would be this 15x and the 13x. And then we've also got this 12 here and the 28 that will combine together as our like terms. So if we do the 15x plus the 13x, we get 28x. And then we want to add together also the 12 plus the 28. So if you add together 12 and 28, we get 40. And then all of that is still equal to that 180 degrees that we had, because it was along a straight line. And then we want to go through and isolate our x, get our variable by itself. So next we could subtract 40 from both sides of the equation to get that 28x part by itself. And then like normal, that 40 and the minus 40 cancel out, because together those would add up to 0. So 40 minus 40 is 0. So the left hand side, we're left with the 28x. And then on the right hand side, if we do the 180 minus 40, we get 140. So we have that equal to 140. And then, like normal, divide both sides by that number in front of the variable. So divide both sides by 28 here. So again, if we divide a number by itself, divide that 28 by 28, those will cancel out, because 28 divided by 28 equals 1. 1 times the x is just equal to x. So I'll write that off to the side here. I'll move that up over here. So for our x here, we have x equals, then we do that 140 divided by 28, and we get x equals 5. But like the directions say, find the measure of each of those angles. So once you get that value for x, we then need to plug that back in to then get our value for the angle here. So if we do that, we'd have our 15, and then times the value for x, which was 5, plus 12. And then we'll plug that in. If we plug that in, we get 87, and then be in terms of degrees here, because we're talking about an angle measurement. So make sure to include your units like normal anytime whenever units are involved. And then do the same thing with our other angle. We'd plug in 5 for the x values, so we'd have 13 times 5 plus the 28. And then calculate that out. If we calculate that, we get 93 degrees there. And then you can either just write it like that and circle your answers, or you can write the answers in to the actual angle measurements there on the diagram. Either way works there. And then for the next one here, we want to classify the triangle here. So there's a couple different ways that you can classify these. in this case, since we have 30 degrees, 70 degrees, and 80 degrees. For this one way to describe that would be as a scalene triangle. Once again, make sure to explain your answer because all the angles are different. We each have different measurements there. Or another way that you could have described this is as an acute triangle, because all of the angles are less than 90 degrees. So anytime whenever you're doing these types, there's normally a couple different options. Sometimes there's only one if they're just the sides given instead of angles. So if they're all different, then it'd be scalene. If they were all the same, it'd have an equilateral triangle, in which case they'd all be 60 degrees and it'd still be an acute triangle. Or if you have a 90-degree angle as one of your angles, it'd be a right triangle, that sort of thing. So make sure to review all of those different possibilities whenever you're dealing with triangles for that type. For the next one, we want to, well, we're actually given what the area of the triangle here is, 72 square feet. And we have that the base and the height are both the same length. We're labeling that as B here. And we want to figure out what the value of B is. So remember, first of all, that the area of a triangle formula is that the area equals 1/2 times the base times the height. But in this case, both the base and the height are both labeled as B. And we have what the area is here. So we'd have 72, that's the area, equals 1/2 is still in the formula, but it's going to be times B times another B. So you can write that as B squared, because anything times itself is that value squared. And then to go through and solve this, first thing we could do is multiply both sides by 2 to get rid of that 1/2 there, because the opposite of multiplying by 1/2 would be to multiply by its reciprocal, which would be multiplying by 2. And if you multiply the right hand side by 2, you're also multiplying the left hand side by 2. Or that would be the same thing as saying that you're dividing by the 1/2 and then multiplying by the reciprocal to do that division. Either way is same thing, and then the 1/2 times the 2 cancel out, because 1/2 times 2 is equal to 1. 1 times the B squared leaves this with just the B squared on the right hand side. So again, we're using B there because we had both the base and the height are being labeled as B in the problem. And then we want to multiply the 2 times 72 there. So if we multiply those together, we get 144. And then to get rid of that squared, to cancel out that, to get just B instead of B squared, you want to do the square root of both sides. So if we do the square root of 144, we get 12, and then make sure to include your units like normal. So we'd have 12 feet. Be what our B would be equal to. If it ends up being a square root that does not give you a whole number, you can just leave it as the square root or rationalize that, simplify that square root down, or you can approximate it as a decimal. Just make sure to use that approximation symbol if it doesn't turn out to be a whole number there, since I don't specify what form to say it in the directions there. Once again, our answer here would be then 12 feet for our B, which is both our base and our height in this case. And then for the next one, number 4, here we've got that a tree cast a shadow of 34 feet. And we had at the same time, we've got a vertical 5-foot post that has a shadow of 11 feet. And we want to try and figure out the height of that tree using similar triangles. So it may be helpful to kind of sketch this out if you're a visual person. So we've got, for the post, we have that it's 5 feet tall. I'm just going to write it as 5 for now. And then we've got the shadow of 11. And then for the tree, we can do that as a little bigger one. We don't know the height of the tree, so we can label that as X, but we know the shadow of it is 34. So this might help you to figure out how to set up the proportion here. But you definitely don't need to draw that out, but it may be helpful for getting it set up correctly. So one way to express this would be as 5/11 for the height and the shadow of the fence post. And then for the tree, the height of the tree is X, and the 34 is the shadow. You want to make sure to match up those like values for the shadow with the shadow, and the height with the height for each of those. And then we can go through and cross multiply. So we do the 5 times the 34, and the 11 times the X to cross multiply those here. So if we do 5 times 34, we get 170, and then 11 times X gives us 11X, and then like normal, we want to divide both sides then by the 11 to get the X by itself. And then here in this case, we'd have a fraction here. So like normal, you can either write it as the fraction here in this case, or you can approximate it as a decimal. So this fraction will not simplify. So as a fraction, it'd be 170/11. If the fraction can simplify, make sure to simplify it. But like normal, make sure to include your units. So our units would be feet here. Or if we wanted to approximate it here, get an approximate answer by rounding it. So it'd be about 15.45 feet. So normally if we round, we want to go out at least 2 decimal places whenever we're rounding. The further we go out, the more accurate it would be. And then that would be in terms of the height of the tree here. Which would make sense here because it should be shorter than the shadow because the height of the fence post was shorter than its shadow. So that'd be a way of checking to make sure that your answer at least makes sense for the problem. And then for number 5, for our last one, trying to figure out the volume and surface area for a rectangular solid that has a length, width, and height of 4 meters, 5 meters, and 7 meters. So for the volume, you need to do length times width times height. Doesn't matter what order you multiply them in, so we'll just do it as 5 times 4 times 7, because multiplication is commutative, so the order that you multiply them in does not make a difference since they're all being multiplied either way. So in this case, if we multiply those out, we get 140, and then like normal, make sure to include your units as well. So we'd have cubic meters, or meters to the 3rd power there for the volume. This volume's always cubic units. And then for the surface area, we do 2 times the length and the width. So we do 2 times the 4 times the 5 plus 2 times, we're going to match up each of these. So we'll do 4 times 7, and then we'll also need to do 2 times the 5 times 7, because if you think of it, if you have a rectangular solid, we have 6 sides to it. We have the top and the bottom that are the same size. We have the left and the right side that are the same as each other, and also the front and the back that are the same as each other. So that's why each of these are being multiplied by 2, since we've got 2 of those that match up for each of these. So if we multiply that out for the first one, we get 40 plus, and then for the next one, if we multiply that out, we get 56 plus, and then for the last one there, we get 70. And then combine all those together to get our final answer for the surface area. So we get 166 and then make sure to include your units as well. So it'd be 166 square meters, or meters to the second power. Because surface area, just like regular area, is always your units squared, or square units. Whereas the volume, like the last problem here, is in terms of cubic units instead. And like normal, make sure that you are showing all your work, and make sure to ask if you have any other questions